Let me continue what or where I had left yesterday. I'd like to point out that somewhere in your mind or somewhere on a chalk or on a this thing, you need to have things like this, a concept. I think some of you may have understood what it is. It's a thermometer with a probe that can be removed. So I have a probe here, then I have a thermometer. I am not much about about the technology behind it. The technology could be, it is there is some sensor and there is a long wire, and since we are talking about packaging and making a good reliable and this thing about an electronic enclosure, you need to examine, as I have said, prior art which is there. Part of it may be patented, but patent is now released, as such you can do. So your first thing, one of the first things you notice here is that there is a display. If I can have a little closer view, sir, as close as you can get. Yeah, you have seen that we have a display, then have keys, then there is something here, and then there is something about a branding. It's generally a generic product, and then you have the the probe. The probe can be put inside even a microwave oven. So if you are good for cooking food and all anything, typically if you have a cake, it's possible for you to poke it inside, but generally you are not expected to leave it inside. You put it inside and then take the thing. Hence we have a wire. This is where you need to pay a little attention about what is the materials that is used and then how it is and so on. And then at the back a few features have been added. One of them is that it already has a clip for holding it onto, let's say you want to check the airflow or somewhere, we have a clip. And then added to something a little related to that is we also have a stand here, so that I can hold it on a stand. And then most important is this is a place where you need to put a single cell, and due to various constraints they have given a extra place for probably it is a cable and all that. Eventually when it sits, it nicely snaps in place. There is a place here, I will stop it here. Oh, it does not want to switch off. I hope now it is switched off. At this point I would like you to take a look at a few of the pictures. I went down and took off a similar equipment which had failed earlier. This is what you are likely to find inside when you open it. You have seen this. Then if you see the sequence, I will again get back to the beginning. As soon as you open it, there are four fasteners, and then the fasteners are holding it at these corners. Oh, my mouse pad is not working. Yeah, now it works. So you see here we have a fastener here, the other side there is another fastener. When we open it, we will notice that it comes up, and one of the things you see is that you have a place for a single cell here, and then something here which will help us we have a beep sound and things work and all that. And then you see here, this is where that clip sits here. Understand? There is a small clip here. For the clip to be mounted and to go inside, this is the place we have here. And then adjoining that is again, there's a small beeper. Probably it shows if you have a set time, set temperature, it sits here and all that. Why I am showing you this is, you see the tremendous amount of detailing that has gone inside. Things are expected to fit. Especially in manufacturing, you have tremendous tolerances, a variation is there, manufacturer to manufacturer variation is there, and in fact batch to batch, material to material variations will be there. Everything, however, is supposed to fit miraculously. And then you see here we have some soldering here, and then we have something which is shrouded there. Once we completely separated, see some other features also we see here. You see here there is a printed circuit board in which there are a row of pads which are attached here, and similarly at this point you have the 1, 2, 3, 4 some switch contacts are mounted, and matching with that on the other side we have this red keys. You have seen this, we have the red keys, then we have a display, and then at the bottom of this one is covered by flexible elastomer material, and inside we have a contact pad. So this contact pad operates the keys, and then very important here is, and why I am showing it here is, a lot of times LCD is not a separate module like what I tried to show you earlier. This has a probably a small reflective pad, contacts, and then that is the LCD plate which you need to just take out. There is no firm connection from this point to this point, there is no firm connection, it is only the pressure of this one more elastomer connector. Since they do not carry current, all that it needs is a voltage. So I have a strong row of pads here, and eventually it is supposed to work the way it is supposed to work. You have seen that. So we have a printed circuit board on which several pads are printed, and then this is the device which just goes and sits there. It is slightly different from this one which I started with the other day when I wanted to show you this. Here there is a composite picture which I liked. I would like to acknowledge that it has been taken from the internet, and retrieved it at this point. All the necessary things are shown here. Can you see here? One of the first thing is it is placed on a circuit schematic, and there is an LCD display. Unlike the other display, this LCD thing including the drivers and all is directly mounted. Inside this, it is a little like what I have shown you there. In the integrated product you need to build everything, but in this case of these you need to work on this. So before that we take this plug-in board, and then we try to make sure that our circuit works. How to drive the circuits? I think I showed you already. So if you go to display catalogs, the display catalogs will give you the necessary information about hardware mounting requirements. So the height is 36 mm. The earlier one what I showed you in the just previous lecture was 37 mm. They are approximately, the height is about the same, and then the width, this is probably a 20 character, the other one is different. Width here now is restricted to 83 millimeters. And then you see total height, height from the front, all of these are available online. Allow me to show you, because the time has come that we need to gather as much information about all the details as we have here. So this is a, I'm not sure which is the manufacturer, but you notice here that we have some contacts here, then mounting holes, and then see what we have here. It looks like it's a flexible what do you call circuit board, which makes contact here and then makes contact here, and then you are allowed to play around with it. So at the back various details are there. Why I am showing these details at the back is you have to make sure that things don't short circuit. And see here, I thought it's about time that we need to think about several alternatives also, so that it should not get boring. I am sure you have gone to, just allow me to go a little, to several retail places where you have a conveyor and then you have something, a thing sticking out like this which will show you. And then why do we need to have this? Now things with built-in display for the customer is also available here. I am happy about it. It's not as if the last display has been made. These are also useful, and probably at the base, you have a base here. Oh, where is it? Oh, I am to move my hand here. You have a base here, you have something here, and then probably there are some connections by which separately you can use the, what do you call that, monitor can be done, or you can use the other one also. So I think I'll probably this is one of those, more and more of those catalogs. Seen this? They are out, too many, they are out there. If you search, this many you have to find out. Now it is for you to make a, what you call and see how best you can fit there. I will take you to another interesting thing which I tried to show you yesterday. You have seen these beautiful things? So I have all these options are available for you. You can overlay sheets, and you have keys, and you have the one I have got from the thing. It will come towards the end. Just be patient with me a little. It looks a little like what I had shown you yesterday as part of the CNC machine. So all these things, anything you want, there are keys here with a small LED button there which shows the button will be lighted up. Then you have the normal input button, then you have function keys. All these displays, if you can try, it is available on the online. Probably you start here. Now I will skip to the actual now you agree with me? Starting point is that locate the display, and then after locating the display, find out how much of space is required for us. You have seen this, how much space is required for us, and at that point itself, see if you can organize some of these layers and the way you would like to organize the whole product. And then I would like to acknowledge that I am using one of the softwares which is a student or instructed version of it, and I fully acknowledge the the effort that has gone into it, and then I suggest all of you spend enough time and then try to make things here. Then I also showed you how to try to arrange these things. So at this point I would like to probably see what a beauty of it is here. Not impossible. You have seen this? It looks quite like what I am likely to have. If I see the side view, it seems to have an organic form. Then I have something here. Then at the bottom, can you see? And the other side, anything you want is already ready here, except one thing. Intentionally detailing regarding where you will mount the things and all that have been avoided, because it was part of a simple shell exercise. So you see here we have anything you want, it is for you to dream up these things. See what has happened? What I have done here is, I have started with two lines in this view. You have seen this? This is where it helps to have a layer which is a concept layer. In the concept layer, we try to attach all the construction lines will be there. After that, using several techniques, a surface has been created here, which looks a little like a real surface. Actually, this being a simple surface modeler, shell command is not available. You have to do a little bit of circus like what I have shown you. And then what started as a simple layout has been projected into that. One more small thing has been done here. While for purposes of illustration, I have shown you an opening here. Inside this also, sorry. Depending on the program use and depending on the various facilities we have, it is possible for us to use all the various effects that we are thinking of making it. In this case, I will just show you that there is a nice command called as split command. So I take this surface for splitting, then I take the cutting objects. I have a split surface already. Can you see here? This is how that complex structure, what I was telling you, has been made. I think at this point, this much of surface modeling is sufficient for you. And to make you, I suggest, if you are a learner, student and all that, if you are an institutional student, you can probably insist to your, you will find several of these programs which including Dassault, Siemens, and this one is McNeil Associates. Dozens of these programs are available, and you need to get hold of one. And once again, I would like to insist that pay for it, because somebody has spent tremendous amount of effort to make these things available for you. And this is not just advertising revenue. And then most of these things allow you a 30-day limited trial, limited saves and limited trials like that. So once you get used to it, I am sure the institution will be happy to finance this for you. Alternatively, maybe you can form a group and then buy one of these things, because they are not very expensive. Any of these things, the student versions and the instructor versions are not useful. I feel I am helping both your students and the person who has made it, saying, you see the power of this, and this is not a hacked program. Long ago, see, we've been using it for 10 or 15 years in another place. I have got the licenses from there, and I'm using it. See, from here you can take off and try to decide to build the remaining model. But then remember, what I have shown you is not a end of anything. You understood? It's not the end, saying automatically nobody can do anything with these things. Usually we start with a circuit like this. Can you see this? So one of our students is trying to assemble together. Me being only packaging, I won't call myself expert or specialist. Somebody who is curious of packaging. Honestly, I have no idea what this circuit is and what this red little thing is, and then what this funny looking thing is, and why in a very clever way he has pushed another LED in these leads among these LEDs. I have no clue what it is. And then there is something else also here, and then that is powered, and I think in another lecture I told you what those are. Slowly I think you will understand that we have one circuit board, then we have one more circuit board. This looks like a camera and this looks like an LED light, and then you have the main board which needs to be packaged along with this. This was made for a demonstration by another batch of students. So this is, you see here, everything is tiny compared to what we know. Everything is very, very, very tiny. You've seen here. That is reality. Reality is you have to work hard. Automatically things don't fall in place. Eventually, if you can think up of something and then try to make things, it's possible for you to run it in this machine. I think some of you who are familiar with it may have noticed what this machine can be. Oh, let me get out and see. Yeah. Yeah. It didn't come, so you're happy. That one was a fuse deposit modeling machine. I thought I'll just stop it here and then go back again to a point here, and this time instead of talking about the organic shapes of all the that I've seen very complicated, nice, beautiful shapes I've shown. If you want to quickly get it done in a fabrication shop, you can either make it in sheet metal or you can make it in assembling together plastic sheets. One of the earlier lectures I showed you how the beagle bone people make all those things together, and I'm sure if you are a serious hacker or enthusiast, you will be. Hacker means it's not about ethical, unethical. Somebody who likes to tinker around with these things, you can make them in your own place. So I'll just start again one more quickly. I'll try to tell you at this point. Let me stick to trying to make a simple enclosure, except that I'll try to go a little faster. I have a profile of a thing which looks a little like a calculator, and I will see whether I can make a sheet metal device out of this. If you again recollect yesterday's show, in which I have shown you an LCR bridge, and at the bottom there is a small adapter box which was made with two parts of sheet metal. You had one on the top going inside the other one, then we have this bottom one, and then I'm sorry it was like this because we needed to put the connectors, and then some very clever way they have made a fastening for both of them. Details are not here, except that approximately I know the shape and size of it. So I now go here and see whether see slowly concept I want in general is picking up. How? So I have one line representing the left, and then I have one more line which oh, just a minute. I seem to have oh, I'm not able to get rid of that color. Oh, forget it. I thought I'll switch off the grey color. For some reason I'm not able to get rid of it. I'll see. Oh, huh. Right. Okay, I have a beautiful empty screen here where you can probably see these things. I'll just start here, which will be easier for me. Again, the same thing which I have done in the other program. This is slightly better. Seen this? So slightly better at this point. And what I'd like to point out here is, depending on various constraints, especially starting with the display and then the total area that is required. Again, in the previous pictures I have shown you, as a schematic, somebody has tried it in a what do you call genuine breadboard or proto board and wish board. Then they have got it all working. After that, you have a genuine estimate of what are the components, sizes and all that is required. And just earlier, just before, I have shown you where you buy things which are already tried, tested, and then try to do a system design by which you try to put all the things together, and then your focus is on, instead of the hardware which is already tried and proven, on how to integrate it and how to use it for useful products. So, in this case, I generally have a small idea of how big or how small the product is going to look. At this point, in fact, it is in order if I can dimension these things. See, it is small, 28 mm wide, and 52 mm long, small tiny thing, little bigger than the temperature indicator I have shown you. Starting here, now let us say from various practical considerations, it does not appear to be very convenient for me. It looks small. Maybe I need something which is a little longer. So, I made it longer, and then you see, without compromising on the total length, I have increased the display area. I will even make it little wider than what I need. You have seen this. What started as a small size, slowly I noticed that it has become a little bigger than what I need, and similarly height does not appear to be sufficient for me. See, does not look very proportionate. So, I will go back to the old thing where we have started. Okay. Better. What I wanted to do was, I wanted to maintain the proportions but try to make them a little bigger overall like this. Then fortunately we have beautiful things here saying I can always scale it in 3 dimensions. So, I take all these objects, keep it here, make it twice as big. Oh, not bad, 124 by 78. Parts of these things have been maintained, parts of it have been restored. See this, I am on the way. Now, I need to see whether it is possible for me to convert it into a sheet metal exercise. For the top portion, obviously it is going to be one long sheet metal which will come like this, which is relatively easy. All I need to do is select a line, there's a small semblance of this one trying to look like a sheet metal part. Now comes to the other point, saying can I now use it for practically creating sheet metal parts. So you'll notice here is we have the side profiles, and if you remember the sheet metal what do you call the exercise which we were talking about earlier, a lot depends on thickness, what thickness overlaps what, and whenever you bend there is a little bit of empirical as well as a theoretical thing about what happens to the material in the corner. So it's possible for us now trying to what do I do now? Can I make it flat? Yes, I think yes, we can easily make it flat. It's a question of taking all these things, say everything is bent like this, I need to make it flat, and then I have the basic dimensions which have come about, and then try to make a flat sheet out of it. I will just show you in profile to see. Seen this? Oh, I will do the other way. Instead I will go to the dimensions, go to dimension properties, and then try to default so that it is visible. I will try to make them a little bigger, 4 times as much. You have seen that is 22.36, no harm in it. Now once again I try to go on continuing with these dimensions. Very odd, yet so it's for us when we are talking about the proportions, how to decide on how to make the proportions.